Good morning. Today we will discuss vector calculus. What is meant by calculus? Calculus is a branch of math. You must have learned algebra, geometry and all in math. Calculus is also a branch of math. In algebra, we have seen how to add two quantities, subtract, multiply, division and all. And we have already discussed the addition, subtraction and multiplication of vectors. And let us see some other operations that can be done on vectors. You must have learned in mathematics something about calculus. Do you remember what they were? What kind of calculus you have learned in math?
Differentiation, integration.
Yes. So calculus itself can be divided into two branches, that is differential calculus and integral calculus. So you already know integral calculus. So you already know what is calculus, what is differentiation and what is integration. We will just go through that very fast. Calculus is usually called the mathematics of differences. So whenever there is a difference, for example, a body is moving, so its position has a difference, then we can talk about calculus. It's called the mathematics of differences. Also, it is called the mathematics of infinitesimal, means very small. So we have, whenever there are differences and they occur continuously, then we can use calculus. Differences and infinitesimal. In such cases, we can use calculus. For example, we know that there is, when an object is moving, it gets displaced, right? So suppose a body is moving, or one of you are going from home to school, and it is a straight line from home to school. It's a straight path, and you take around, it's around 600 or 6,000 meters, around 6 kilometers from home to school, and you took around, say, 10 minutes. 10 minutes means 600 seconds to travel this distance. So when you are asked about the velocity, you can say, well, velocity is equal to displacement by time interval. You can directly find. But at this position, what is the velocity? If after, say, 100 seconds, what is the velocity? If such questions are asked, you have to tell at that particular position, that is an infinitesimally small time gap, what is the velocity? It's very difficult to tell from this equation because the velocity may not be a constant as you go from one place to another. It will be changing continuously. So at a particular instant, what is the velocity? If that is the question, then you have to take this time interval narrow. So from 100 second to 100.0001 second. So the time interval is very small. So you have to take the limit delta t tends to 0 delta x by delta t. This infinitesimally small time interval, the change in displacement is usually represented by dx by dt. And we call it the rate of change of position with respect to time. That is the velocity at an instant, or you call it instantaneous velocity. Here we used an operation called d by dt, which is called a differentiation. So differentiation is an operation. What is meant by operation? We take squares of something, right? If I just write like this, it doesn't make any sense. But if I take 3 here, 3 square is 9. So square is an operation done on 3 to get the answer 9. Similarly, if I take root of 25, root itself has no meaning, but if it is acted upon some number, it has a meaning. So these are called operations. So today we will learn a few vector operations or some operations which are definitely used in particular for vectors. So we have, you already know about the differential operation, may be written as d by dx, and integral. This is how you represent integral of dx. And there should be something here, and here there will be something. And you must have learned several formulas also related to differentiation and integration, which we will be using in different parts of physics. Now, I'm not going into the details, but what you must not have learned in math or when we discuss different parts of physics is something called partial differentiation. So I want to focus only on partial differentiation in today's class. Have you learned partial differentiation before? Have you learned partial differentiation?
No.
Okay. Partial differentiation is represented by dou by dou x. See, this is complete differentiation d by dx. Suppose you have a quantity u, which is a function of x. Then you take the differentiation of u. This is, suppose this is equal to 2x square. Then when you do d by dx of u, you will take 2 into 2 is 4x. Right? Here, u is a function of x only. And you are doing the differentiation of u with respect to x. And you will get it as 4x by using the laws of differentiation. Suppose you have a function a of x, y, and z. Suppose you have a function a which is of x, y, and z. This is equal to 3x square y cube z. This is the expression. So, when you differentiate with respect to x, you cannot take y and z as constants because we know that they are not constant, they are variable. So, in such case, this comes into help. When you take partial differentiation, you can assume all other variables other than x constant. For example, I am taking partial differentiation of a with respect to x. What is a? A is equal to 3x square y cube z. In that case, I can consider y and z as constant. I will differentiate only x square. So here I can consider 3y cube and z as constant and differentiate only x square. So what is the differentiation of x square? 2x. So 2 gets multiplied with 3 and you will get it as 6, and then x is there, y cube z. So this is how you do partial differentiation of a function which is a function of more than one variable. Then you can consider all the variables other than with which you are doing the partial differentiation constant and then just differentiate. Now, can you tell me how to differentiate this with respect to y? Suppose I am differentiating a, partial differentiating a with respect to y. What will be dou a by dou y? We don't call it d. This expression is called dou or del. So dou a by dou y. Can you tell me what it will be? Here you can consider x as constant, z as constant. So 3x square z will be taken out, and you need to differentiate only the quantity containing y cube. Now can you tell me what is d by dy of y cube? D by dy of y cube. It's 3y square. Tell me whether you are familiar with differentiation. Do you know differentiation? I'm taking this class with the assumption that you know differentiation.
Yeah, teacher.
You know? Then tell me what is d by dy of y cube?
3y square.
3y square. So 3 goes multiplied with 3, so it will be 9. Then x square, y square, z. This is how you can partially differentiate a function with respect to 1. Now, can you tell me what is dou by dou z of A? So here x and y are considered constant, only z is considered as a variable. So you can write 3x square y cube dou by dou z of z. What is dou z by dou z? 1. So this will be equal to 3x square y cube. So this is how we do partial differentiation. So based on the partial differentiation, there is a operator which usually acts, which is called differential operator or partial differentiation operator. We will see how we can do with this partial differentiation operator on vectors and scalars. So how you can do this operation with partial differentiation. So that operator is called a vector operator. Del. It is represented by this delta and you call it del. Okay, and this partial differentiation operator del is equal to, del means dou by dou x I cap, there should be something here, plus dou by dou y j cap plus dou by dou z k cap. See, there is I, j, k, unit vectors along x direction, y direction and z direction. So this del is called a vector operator. Now let us see how this del vector operator can operate on a scalar quantity. Then we will see how we can operate this vector operator on a vector quantity in two ways. We can take both the dot product and cross product. First of all, let us see how this vector operator can function on a scalar quantity. When a vector operator functions on a scalar quantity, we call it gradient. Gradient of a scalar. Gradient of a scalar. Suppose there is a scalar quantity phi. Phi is equal to 4x square y cube z square. This is a scalar quantity. For example, suppose this is electric flux. Electric flux is a scalar quantity, you know that. And it varies with space. So this is how it depends on the x coordinate, y coordinate and z coordinate. So this is an example for a scalar quantity. Now let us see how to take the gradient of a scalar quantity. When you take gradient of a scalar quantity, you represent it as grad phi, or you can also call it as del phi. So this is equal to, when you take grad phi or del phi, you have to do this operation on this. So let me show you how to do. So first you have dou by dou x of I cap plus dou by dou y of j cap plus dou by dou z of something into k cap, and you are doing that on the scalar quantity 4x square y cube z square. First, you have to differentiate the scalar quantity with x, with respect to x. So when you differentiate this with respect to x, what it will become? X square, you have to differentiate. You will consider y and z as constant. So this will become equal to 4 is there. What is d by dx of x square? D by dx of x square is 2x.
Wait.
Yeah. So I will write 2 into 4 will be 8. X, y cube, z square, I. Plus, now we have to differentiate this with respect to y, and we will consider x and z as constants. So 4x square will be there, z square will be there. What is d by dx of y cube? D by dy of y cube? 3y square. So instead of y cube, we will put it as 3y square. 3 multiplied with 4 will give you 12 x square, then 3y square, right? So y square, z square, j plus. Now dou by dou z of this quantity. So x square and y cube, we will keep them as constant, and we will differentiate with respect to z only z square. What is dou by dou z of z square? 2z, right? So 2 gets multiplied with 4, so 8. So x square y cube like that, and this will become z and k cap. Don't forget to put the I cap, j cap, k cap. My question is this a vector or a scalar? Is this a vector quantity or a scalar quantity? There are I, J, K unit vectors showing direction. Is this a vector quantity or a scalar quantity?
Vector.
Vector.
This is a vector quantity. So if you take gradient of a scalar quantity, it becomes a vector. So if you want to change a scalar quantity to a vector, you can take its gradient. You can take gradient of a scalar quantity. The word is gradient. What we are doing is del phi. So you have to remember how to do this. Is this clear how to take the gradient of a quantity? In physical terms, the meaning of gradient is the change. It shows the direction in which something is changing at the higher speed. For example, if I take the gradient of electric field, I will get electric potential. Sorry, the other way. If I take the gradient of an electric potential, because potential is scalar, right? So gradient of electric potential will be equal to electric field. I can tell that electric field E is equal to, E is a vector, is equal to, in fact, it is minus del V. Okay, so minus, oh, I put it as a triangle, right? I'm sorry. So the triangle put in the reverse direction, that is del. So E is equal to minus del V. It's not as a triangle, I'm sorry. It should be put as a reverse of a triangle. Triangle put upside down. So it is electric field E is equal to minus del V. See, V is the electric potential. And if you take the gradient of the electric potential, you will get electric field. See, minus del V. Del V means what? The way in which the electric field will change at the higher speed. So, or you can also call it as the slope, the way something change in the steepest way is called the gradient. So, gradient of a quantity is equal to the change d by dx of I, dou by dou x of I, dou by dou y, j, dou by dou z, k. You have to do that on the scalar quantity, then you will get a vector quantity. Now, if the gradient of a quantity is 0, suppose del phi is equal to 0, what does that mean? I told gradient means the way it is changing at the highest point. Del phi equal to 0 means each of this is equal to 0. Dou by dou x means rate of change of quantity with respect to x-axis. There is no change, 0. Rate of change of that quantity along the y-axis, that is 0. Rate of change of that quantity along the z-axis, it is 0, which means that quantity does not change with space. Suppose the temperature in a room, if the temperature throughout the room is same, if it is a constant, then if we take the gradient of temperature inside the room, it will be 0, which means it is not changing. So if we have a constant value, if I take the gradient of that constant scalar quantity, it will be 0 because it's not changing. It's a constant. You know that d by dx of pi. What is that? Pi is a constant, right? It has value 3.14. What is d by dx of pi? It will be equal to 0. D by dx of 4. What is that? 0. Similarly, if the gradient of a scalar quantity is 0, it means that scalar quantity is constant in space. Is that clear what is meant by gradient?
Yeah, teacher.
Okay. Now, let me discuss another thing, another way the del or the vector operator del can act upon a vector. We saw how the vector operator del can act upon a scalar quantity. Now let us see how the vector quantity can act upon a vector. As I told before, it can act in two ways. We can take the dot product or the cross product. First, let us see what will happen when we take the dot product. Now, when we take the dot product of del with the vector, we call it divergence. Divergence. So, take the divergence of a vector. Divergence of a vector means we are taking the dot product. Del dot A. Del, you know, the operator del is a vector. Sometimes they show with the arrow. Even if without a arrow, you have to understand this del means it's a vector operator. It is equal to I dou by dou x plus j dou by dou y plus k dou by dou z. Now, suppose this vector operator is taking a dot product with another vector. Let this vector A be is equal to vector A is equal to AXI plus AYJ plus AZK. And del, you know what is del? Vector del is equal to dou by dou x I plus dou by dou y j plus dou by dou z k. Okay. So here you have this is equal to, this will be equal to, we have to take dot product. What is I dot I? I dot I is 1. I dot J,
1.
0. I dot K, 0. So this, when you take dot product, it will be dou by dou x of Ax plus dou by dou y of Ay plus dou by dou z of Az. Now since A dot B is equal to B dot A, right? A dot B is equal to B dot A. So even if someone write A dot del, you can just write it as equal to del dot A and do this, because del A dot del or Ax into dou by dou x doesn't make any sense, because dou by dou x independently have no role. It should be acting upon something. So you cannot write Ax into dou by dou x. It has no meaning. You have to always write dou by dou x of Ax. Now I will take an example and show how we can take the divergence of a vector. Suppose you have a vector A, or vector, I will mention vector P. Vector P is equal to 2x cube yi plus 3x y square j plus 4z square yk. This is a vector. Now I am taking the divergence of this vector. So I am going to take del dot p. What is del dot p? I have to take dou by dou x of this quantity. So dou by dou x of 2x cube y plus dou by dou y of 3xy square. Will there be ijk? No. When you take the dot product, which is called the scalar product, the result will be a scalar quantity. There will be no I, j and k. So this is equal to dou by dou x of this, dou by dou y of this, plus dou by dou z of 4z square y equal to. So when I take dou by dou x partial differentiation, I can consider y as a constant. So it will stay out of differentiation. I have to differentiate only x cube. What is dou by dou x of x cube? 3x square. So 3 multiplies with 2, giving it 6x square y plus. Here I am differentiating with respect to y. I can take x as a constant. So dou by dou x of y square will be 2y. So 2 multiplies with 3, giving 6xy plus dou by dou z of this quantity. Y can be considered as a constant here. Dou by dou z of z square will be 2z. So plus 4 into 2, 8zy. Is that clear? Is this a scalar quantity or a vector quantity? Is this a scalar or a vector? Is this a scalar or a vector?
Scalar.
Scalar, because there is no I, j, k. There is no direction vectors here. So this is a scalar. So in order to change a vector quantity to a scalar quantity, you can take the divergence of that vector. What is meant by the word diverge? Diverge means different or separate. If something is going out of somewhere, we can call it, it's the divergence of that quantity. For example, electric field. We can tell the divergence of electric field can be is equal to rho by epsilon naught, where rho is the charge density. Divergence of electric field is equal to rho by epsilon naught. You need not study this. I just want to give them a physical appearance of what is meant by divergence. Suppose I have a positive charge sphere here having charge density rho. If it is positive, if I take the electric field, it will be going out in this all the directions, right? So what is going out is called the divergence. Divergence of electric field depends upon the density of the charge in the middle. Okay, and this can be, if it is going out, the divergence is positive. Suppose I have a negative charge, solid negative charge. If I take a sphere, we know that the electric field will be all pointed inwards, right? So if the divergence will be minus rho by epsilon naught. So it's a negative quantity. So when the divergence is negative, it means something is coming in. So the divergence is positive means something is going out, diverging out. And if something is coming in, it's equal to negative, means the divergence is negative, means all those things are flowing in. Now, if the divergence is zero, I'll tell that the divergence of magnetic field is equal to zero. Do you know why? There is no magnetic monopole. Magnetic field always exists as dipole, north and south, right? So if I take a surface, then all that is going like this, like this. So if I have a piece of magnet, nothing is coming out. The magnetic field is just not going out. Maybe here from the north pole, there will be something going out. But from the south, something is going in. So the number of field lines going out is equal to the number of field lines getting in. So the divergence, the overall going out or coming in is zero. These are called Maxwell's equation. You need not study that at grade 11 and 12. You may study that when you go for degree. So this means divergence means something which is going out. If it is going out, divergence is positive. Divergence is negative means something is coming in. And if the divergence is zero means nothing is going out or nothing is coming in, or you can tell as many as going out will be coming in. We call all the quantities, all the vectors whose divergence is equal to zero as solenoidal. We call solenoidal. Something is called solenoidal if del dot that quantity. Suppose del dot R is equal to 0, then we can say that R is solenoidal. Solenoid means, remember, a solenoid, the field will be circular, right? So solenoidal means its divergence is 0. Nothing is going out. Is that clear what is meant by divergence of a vector?
Yes.
Now there is one more way we can operate with del on a vector, that is taking the cross product. I will discuss that tomorrow. Okay? The time is getting over, so I will discuss the curl of a vector or how we can do this del operator cross product with a vector tomorrow.